Hello, my name is Matthew Mueller, and I'm the manager of the PTC Education Innovation Team, and I'm joined by my colleague Matt Shields, and we're so excited to talk with you today about how Onshape is enabling cutting-edge academic research and innovative teaching. Throughout the session, please feel free to introduce yourself and interact with other attendees through the chat, which will be moderated by our colleague Peter Zink. And please feel free to put any questions in the Q&A, which hopefully we will be able to answer at the end of this session. So to start today, we'll talk about how Onshape is fundamentally different than traditional CAD platforms, being built from the ground up to be cloud native. We'll then dive a little bit deeper into how some of the core technologies in Onshape are enabling researchers and teachers to do new and exciting things. Then we'll go over some of the exciting examples of academic research happening in universities, as well as some of the innovative ways that educators are using Onshape to teach more than just CAD. So before joining PTC Education, I got my bachelor's and PhD in mechanical engineering from Tufts University, where my research focus was around designing learning environments to enable students of all ages, from middle school up through the university, to engage with real-world engineering practices. Now at PTC, my role is to be the product manager for Onshape's education plans and the features that we've designed specifically for educators to help them teach with Onshape. I also have the opportunity to work directly with faculty members to support their research and teaching to help push Onshape's boundaries to use it in new ways. I'll turn it over to Matt now to introduce himself and kick us off.
Hi, thanks, Matt. Greetings, everyone. I'm so excited to be here today, part of Onshape Live. Yeah, just a little bit about me and my background. I also got my start in mechanical engineering. My first master's degree was in mechanical and aerospace engineering, and I worked as a mechanical engineer for a couple of years before making the shift into the world of education. I have taught for 16 years, both at the high school and university levels. For about 10 years, I taught and ran and coached several robotics teams and science-related competitions teams, such as Science Olympiad and Science Bowl. I also founded and ran the engineering program here in Charlottesville, Virginia, for Charlottesville City Schools for 7 years. And now, before leaving my job running the engineering program there, we transitioned away from a traditional CAD platform to Onshape, and we never looked back. And that's part of what brings me to where I am today. Now, Matt and I are going to share a lot of examples today of some really great innovative teaching and some awesome research happening using Onshape. But before we do that, I would like to briefly discuss what makes Onshape so special, so revolutionary, that enables this type of great innovation of teaching and learning. And for starters, let's go back to thinking about the state of the art for the last few decades. If you were using CAD over the last few decades, the way it worked was you had a big, expensive workstation with a big, expensive CAD platform. That's necessarily how it worked. And if you had a team of developers or researchers or students, each person required their own instance of the software. And so I might have a team of students, and for a lot of schools, that meant maybe 20, 30 students, and that means I needed 20 or 30 big, expensive machines, each with its own instance of the software. Right there, that was pretty cumbersome when it came to installing the software, keeping it up to date, keeping the license up to date. And then when students wanted to collaborate, that also was pretty tricky. I'm working on a file, and maybe I want to work on a file, or I want to share that file with someone else. The way I'm going to do that is I'm going to maybe put the file on a thumb drive or a floppy disk and walk it down the hall, or I might email the file. And that really slows down collaboration and makes it a little bit cumbersome. Now, eventually, we did have servers, and we had PDM servers. So if I wanted to collaborate with my peers, I might be able to work on the file and then check the file into the PDM server. But still, collaboration was pretty much stunted by that process, that someone else had to then check the file out. And we were still stuck with that serialized approach to development, where one person is working on a file at a time, and true collaboration really is impeded. But then let's talk about what happens when you move to Onshape. Now, primarily, it's important to understand that Onshape is way beyond just CAD in the cloud. So when Onshape was developed, we didn't just take a traditional CAD platform and put it up on a server somewhere and say, we've got CAD in the cloud. Onshape was developed from scratch to be cloud native. And that comes with a whole host of advantages. As a teacher, one of my favorite advantages was that I had my students working on their designs on any device. So I have students with Macs and PCs, Chromebooks, and even their tablet and phone, and they were able to collaborate with each other from anywhere, which was so fun to watch. And when you break down the walls of a file structure, what you see is that collaboration isn't just improved. Collaboration becomes embedded in what students do, and I think that's what students like to do, is to be able to collaborate and share with each other. And when you get rid of a file structure, that becomes second nature for students. And so with Onshape, there are no files. There is no file sharing. It's collaboration becomes a breeze. You can't if your computer crashes, you're not losing your files. You're not worried about overwriting each other or stepping on each other's toes. It's really such a more seamless process. And when you move CAD into the cloud, you get a whole bunch of other advantages, such as the modern workflows that like GitHub uses, where you can create branches and do merges. And that's something that students are becoming more and more familiar with, and should be. It's such a powerful and modern workflow. So when you move Onshape into CAD into the cloud, and you have a cloud native system like Onshape, there's so many advantages that come with it. But what I saw when I was a teacher, that it goes even beyond that. And so if you are creating a project of any complexity, or if you're doing research of any depth, you're quickly going to run into the constraints and boundaries of your CAD system. And so what ends up happening is your designs end up getting constrained, and you end up having to adapt to your CAD system, because CAD systems, until something like Onshape, were not flexible or extensible. But because Onshape is so infinitely extensible and flexible, it adapts to you, not the other way around. And what I saw when my students got that, I really felt like their creativity was unleashed, because they understood that they weren't bound by the constraints of whatever CAD system was in front of them, that they could add to Onshape, they could find extra plugins, they could write or find extra scripts, and really it enabled a whole nother level of creativity, of collaboration, and fun in the classroom. So it's really cool to see a platform like Onshape that enables that kind of creativity, because it's so flexible and so extensible. So I'm going to turn it back over to Matt, and he's going to talk about some of the ways, some of the things under the hood that make that type of flexibility possible.
Thanks, Matt. So yes, I'm about to dive a little bit deeper into some of the core technologies that are really enabling this academic research and innovative teaching. So a first question that Onshape developers had to ask when they were building their platform was, how do you parametrically design 3D geometry in the cloud? Their answer to this question actually solved a couple of problems posed by traditional CAD platforms. So let's say you're at the hardware store and they're out of the original material that you were hoping. So you want to edit the model on your phone and update the bill of materials. In the past, traditional CAD platforms have been able to provide CAD viewers on your phone, so you can view and rotate your model, but you couldn't actually edit or interact much with your model from your mobile device. Another scenario is you want to automate a common design workflow that your engineers are going to do over and over again, but you want to maintain a custom interface for parametric control. In the past, you could develop a macro to execute a series of canned tasks within your CAD platform, but you would not have a parametric interface for controlling this macro. So Onshape's solution was FeatureScript, which is a brand new programming language written by Onshape for Onshape. Every standard feature that you see in the toolbar of Onshape, sketch, extrude, fillet, etc., are all written in FeatureScript. And that FeatureScript code both controls the parametric interface that users see when they're using your feature, as well as the geometry that's created. So as you build up a list of parametric features in a part studio, you're ultimately just building up a function that's a FeatureScript function. This opens up a whole number of opportunities, like configurations are now so much more accessible and extensible. But we'll go into an example of that later. One of my favorite parts about FeatureScript is that the code for all of the standard features that you see in Onshape is fully open sourced with an MIT license. It's all housed in just another Onshape document. So you can go see that source code, make a copy, and make your own custom version of extrude or fillet to fit your needs. Commercial customers are leveraging this heavily to drive a lot of value for their customers and engineers. One of my favorite things that you can do is now develop these custom parametric features and tables. So in this GIF on the right, you can see I have this 7-sided extruded shape, and with just 3 custom features, I can go from that extruded block into a flat packed box that's ready to send to my laser cutter and manufacture. And with each of these custom features, I also have a parametric interface to control, in this case, how many tabs there are on each face where they interact. So this is opening up a whole new world of how you can create your own first-class features in a CAD platform. So a next question that Onshape developers asked was, how do you integrate CAD with other systems in real time? So one example use case is you want to pull a range of configurations with different parameters into a simulation and run that simulation to see the impact as you edit your model. So in the past, if you had a very powerful workstation, you would be able to do this, but there would still be a very manual process for data management where you would have to make sure as you edit your files, you're saving them and then reloading them into your simulation platform. Another scenario is you want to integrate your CAD data with a project management tool. John Hirschtick this morning mentioned a number of examples like Airtable, Asana, Google Docs, that are all cloud-native project management tools. In the past, if you wanted to integrate your CAD data with those project management tools, it would, again, be a very manual task where you would have to upload any updates anytime you do them. So Onshape's solution was the REST API. So if you're not familiar, a REST API is a standard HTTPS protocol that's used by pretty much all web applications. And it allows you to integrate any computational workflow, any workflow that's driven by code, directly into Onshape's modeling engine as well as database. So this allows you to, in real time, as engineers are working through the front end of Onshape, you can be running a Python script in the background that's doing any sort of data integrations or analysis or updating to organize your information, all in real time. So this is a hugely powerful part of Onshape that's opening up so much extensibility to make Onshape truly an engineering platform, so much more than just CAD. And a final question that Onshape's developers asked was, how do you audit intellectual property and user activity? So let's say, as a project manager, you want to know which of your team members worked on a project so you could make proper attributions to the final product. Well, in the past, you didn't have that kind of log of who was actually making the most changes and edits to a hardware product. Or let's say you want to know when your team is transitioning from different phases of the design process, from ideation to final design and manufacture. And you want to quantify that exact moment when they're transitioning phases to ensure the proper version control through those manufacturing stages. In the past, you would have to maybe monitor your data management system, but there would be no way to really quantify the different types of actions that your engineers are taking in near real time. So this is why Onshape has now provided enterprise analytics, which are available in any enterprise version, including the education enterprise of Onshape. So this allows you to very quickly customize dashboards to provide high-level insights. So in this case, we have an intellectual property tracking dashboard that allows me to see things like who's exported parts or assemblies from documents, who's copied documents, and from where in the world they're all doing this. We can also see a full audit trail that essentially timestamps and logs every event that a user takes on a document in your enterprise. So this is enabling really cutting-edge research to understand how engineers collaborate and work together and how students are actually learning to do CAD and engineering. So now that we understand some of the core technologies behind Onshape, let's talk about some examples of how researchers are leveraging these in new ways in academia. So before we dive into specific examples, I want to paint the landscape of the fields of study that are really leveraging these new capabilities of Onshape. A first field of study is in computational design and machine learning. These researchers often are in the computer science department, but are able to use FeatureScript and the REST API to automate their computational workflows and generate large data sets from Onshape. So they're using CAD in ways that they couldn't before. We also see a large community of design process and education researchers who are using that enterprise analytics audit trail to quantify how teams are actually collaborating for professional design and how students are learning to do CAD and collaborate through the engineering process. And last but not least, we're seeing a lot of very exciting examples of open sourced applications where they're using Onshape to design innovative devices and solutions. And more than just writing an academic paper for a journal, they can actually share their original design with the community so it lives on, so that they can ask for contributions and the actual design lives on and grows. So I like to show this plot, which was generated from dimensions.ai, searching for any academic publications that cite Onshape. And as you can see, since Onshape was founded in 2014, we've grown significantly in how researchers are using Onshape. And in 2022 alone, we had over 150 academic publications that mentioned Onshape. So to dive into some specific examples, the first one I want to highlight is a case of shape optimization. So if you remember when I talked about FeatureScript, every part studio is just a FeatureScript function. That allows you to use configurations as query parameters or inputs to your FeatureScript function. This makes for a much more efficient way to access different versions of your design just by changing a parameter in your URL. So in this case, we have a squirrel fan that has all of these configuration parameters set up. And this group called Isteco was able to run this shape optimization on the fan using a cloud-native simulation platform called SimScale. So they computationally exported a certain configuration of this pump, ran it through SimScale, which has its own REST API, to understand the performance of that specific configuration, and then plot the results on their own platform. They were able to close the loop then by updating Onshape's configuration options and again running new simulations to optimize the shape of the fan for any specific application. One of my favorite stories here is from a PhD student at the University of Washington who is using Onshape to design metamaterials. So we met this PhD student at an academic conference over the summer, and he was using Onshape to create these auxetic structures. So as you can see on the top, as the model is deformed in the y-axis, there's no deformation in the x, so that's a 0 Poisson's ratio. But then you can change some parameters to make it so as the material is deformed in the y-axis, it also deforms in the x-axis with a negative Poisson's ratio. So we worked with this student to develop a Python script to automate his process. And this is a great quote where he says, using the Onshape REST API, I was able to cut my workflow from a very manual process on the order of hours to an automated and importantly rerunnable process of minutes. This lowers the costs of performing studies significantly and has vastly improved the fidelity of my investigations. It's so exciting to see that Onshape is being used to grow knowledge in various communities. And this was such a great, fulfilling case where we were able to actually help a PhD student save lots of his valuable time. Moving on to the design process and education research community, this is a great example coming out of a collaboration between the University of Toronto and the Technion University in Israel. Their paper was called All's Not Fair in CAD, an investigation of equity of contributions to collaborative cloud-based design projects. So in this case, educators at Technion had students break up into 3 teams of 3 students each and complete an open-ended design challenge. Using Onshape's analytics, we were able to see all of the actions that each student on each team took. An initial finding was that each of the teams had a clear CAD guy. And yes, in all cases, it was a guy. So as you can see, the first row of each of these teams shows one student that contributed a majority of the actions throughout their project. But even more interesting is looking at just the deleting type actions that that CAD guy was taking. And you can see that it was only the CAD guy in each of these teams that was doing any portion of their actions as deleting. So this is early insight, but can potentially provide insight to educators on how they could ensure that students are collaborating and feel equal ownership over their team's design. Another example of an application for Onshape is in the world of bioengineering. So this is a paper called An Anatomically Correct 3D Printed Mouse Phantom for Magnetic Particle Imaging Studies. So in this case, researchers were able to leverage the mixed modeling functionality of Onshape. This is when you're able to import mesh geometry, so an STL file, for example, where you don't have the precise boundary representations, but then you can mix that with parametric features in Onshape. So in this case, these researchers took a biomedical scan of a mouse, they imported it into Onshape, and then were able to modify that mesh using Onshape's parametric features. They were able to precisely control different tumor shapes within this mouse, which then they were able to put into a magnetic particle imaging study to better understand how we can treat cancers in humans. Last but not least, I'd like to highlight this example of the Agua Clara Water Treatment Group. So this is a group that was originally founded in Cornell in 2005, and it came out of a student research group. But since then, they've expanded and now have partnerships with Ohio State University and New Jersey Institute of Technology. And their goal, their mission, is to promote global access to safe drinking water through research and education. And then they partner with local implementation specialists to actually build these facilities in countries that don't have easy access to potable water. So in this case, they've open sourced their library of custom features that actually use the engineering requirements, such as flow rate of the water through the facility, to generate this fairly complex system that can very easily then be built and installed in third world countries. So you could see this entire system is built with just 4 custom features that is all configured so that the geometry is designed based on the specific requirements of the facility they're creating. So hopefully you were inspired by some of this very exciting academic research leveraging Onshape. But now I'm going to turn it over to Matt to talk through some great examples of ways educators are using Onshape.
Thanks, Matt. Yeah, I'd love to highlight a few examples of how Onshape's open architecture, just like we saw some exciting and innovative ways that it enables some really fantastic research, also enables some innovative teaching. For starters, I want to talk about coding. Now, when I was an engineering teacher, I wanted my students to develop expertise in a wide range of disciplines in order to become successful engineers. So I wanted my students to be well-versed in physics, electronics, design, and CAD, and coding was definitely one of those disciplines. And I tended sometimes to teach those things in sort of siloed units of study. Now, with Onshape, because Onshape is such an open platform, it also helped me open up how I did some of my teaching. And coding is a great example. So I wanted my students to learn coding. They had just finished becoming familiar with the basic modeling and 3D modeling in Onshape. Why not use that same platform to teach code? Now, as Matt just described, FeatureScript underlies everything that goes on in Onshape. And so when you create just a simple sphere in Onshape, you're writing code. So why not have the students open up the hood and see how that works? So the script you can see on the screen right now is just 40 lines of code. And in those 40 lines of code, we're generating 125 spheres of 125 different colors. And students can start to see some basic fundamental coding concepts, such as variables, for loops. I've got 3 nested for loops on the screen right now, functions, arguments, etc. And so it was great to see the kind of the blending or the breaking down of the walls between different disciplines when I had my students start learning coding with CAD, and also to see that when they're doing CAD and they're doing just about anything else on the computer, they are writing code whether they know it or not. And one of the nice benefits of this approach was students saw that when they run into a modeling problem, there's often a chance that their coding expertise can get them out of the bind. And so often when you're modeling an Onshape, you might run into a point where you say, you know what, this is pretty tedious or maybe even impossible with the built-in functions. Why don't I write my own? And so students can start becoming familiar with that process. The next example is very similar. Right now what we're looking at is the ability to create custom features using FeatureScript and Onshape, and also custom tables. And again, Onshape becoming a vehicle for education well beyond just simply drafting or CAD. And so here we're seeing a teacher that's teaching some physics concepts to their engineering class, and they want the students to learn a little bit about mechanical advantage and pulley systems. Why not embed the demonstration right in Onshape? And that's what you're looking at. So what you're looking at right now is a custom feature. You might be able to see it. It's called pulley physics. That was written by us and the teacher to demonstrate a few things that they wanted their students to know. So behind the scenes, there's some code that is generating an actual model on the screen for students to experiment with. So in this case, students can experiment with the model, change various inputs, change how many pulleys there are. They can pull on the rope and then see how much the pulley blocks move. They can adjust how much force they're applying to the rope, and then see how much weight they can lift with the applied force. And all of the data is collected in a live table on the right called a custom table. So we've got the ability for students and teachers to work together, generating a CAD model that basically provides them the ability to simulate and demonstrate physics, and to run an experiment, collect data, draw conclusions. It's a really great example of using FeatureScript to blur the lines of disciplines in the classroom. Our next example comes from a computational fabrication class at Boston University. And I love this example. It's in a computational fabrication class. So we're talking a CS class where students are learning some coding and computer science principles, but we're using Onshape to do that. And it's a really great example. And in this project, you can see the project prompt. It's very open-ended, and that is develop an algorithm for producing a physical product. Now, these students were inspired by, you can see on the left there, a guy named Mr. T. Mr. T is a little plastic guy with silicon pants, and he's a tea infuser. So you can put your tea in inside Mr. T there, and he hangs out on your mug and brews your tea for you. Now, the students were inspired by that, but they wanted the user to be able to design their own tea infuser. So they took the fabrication steps necessary to create Mr. T, and for each fabrication step, wrote a custom feature in Onshape. And if you can read it, the top feature is called Add Mug. Now, I don't know of a CAD platform that comes with an Add Mug feature right out of the box, but because Onshape is extensible, why not add something like Add Mug if it's going to be helpful for your process? And then every other step of the fabrication process, students were able to write a feature script that took various user inputs and generated the necessary geometry to ultimately create the tea infuser. And so then you can see that through the various steps, the user can add their inputs. They can 3D print a mold and then cast the silicon parts in the mold, and they've got their own customized tea infuser. So I love this example of students taking some inspiration from an actual product and then innovating upon it using Onshape as an innovation platform. Our next example comes from a teacher here in Virginia talking about simulation, which is available for enterprise users. And he was saying that in his engineering class, every year he wanted to bring in simulation and finite element analysis and statics simulations into his class, but he usually ran out of time. So it was in this engineering class, students were learning design, they were learning fabrication, and they were making these bridges and testing how much weight they would hold. But getting to the final step of actually doing simulation and doing testing on it, he couldn't get there because it was another program for his students to learn, and that was a bridge too far, if you will. But with Onshape simulation, the students were already modeling their bridges in Onshape, and then with a click of a button, Onshape is able to do some real fast, easy, and accurate simulation and speed up the iterative process. And because this bridge was for competition, students could do better in their Science Olympiad competition that they had coming up. All right, the next example I would like to talk about is a custom app, not a custom feature. And so we've seen that because Onshape is built on an open language called FeatureScript, you can write your own custom features using FeatureScript. Now, custom apps take advantage of what Matt talked about earlier, the REST API. Because Onshape resides in the cloud, it can easily connect to any other cloud services. And this has an endless number of advantages, including creating your own custom apps for your own specific purposes. On the screen right now, you can see that someone is building and designing a robot. Now, a lot of times when you're designing a robot, most, if not all of your parts are coming off the shelf. And so if you're going to be designing your robot using off-the-shelf parts, you might be stuck either modeling all those parts from scratch, or you might be scouring the internet looking for the various off-the-shelf parts that you need for your robot. So you might be looking at different vendors, and that's a really time-intensive process. This custom app actually goes out onto the internet and keeps a database of various vendors and various parts, dramatically speeding up the process of modeling and designing the robot. So this robot is made almost entirely of parts pulled in using the REST API through a backend database, presented in a nice right panel app to the user. The user can grab parts, model it in, and keep going. It's a really slick interface. Let's take a look at one more custom app. This was actually designed by some students at Tufts University. I love this relatively simple but real deep example of what you can do with custom apps and the REST API. So we've got a relatively simple 4-bar linkage designed in Onshape. So we've got those 4 bars all modeled in Onshape, different links. And we want to see we want to create a kinematic study. We want to see what is the output of that kind of right orange pin when I take the left input through 360 degrees. What's going to be the output? That is actually not by default possible in Onshape. So the students wrote their own custom app. So the app, as you can see, takes the Onshape model and modifies that mate that causes the left leg on the leg on the left to go through 360 degrees in 8 steps. That's a variable in the app. It goes through 8 steps and it goes through 360 degrees. Then the resulting geometry is then captured by the app and then plotted using a Python, just a simple Python plot. And so if you want to know, given those 8 rotations, what the orange output is going to be on your 4-bar linkage, write a custom app, send the bar through the rotation, gather that data, and plot it. Really great example of writing a custom app. Okay, the last example I would like to show is on the screen, and what you're seeing is a really fun and fun challenge that some students at Tufts also saw, and that was on the left you can see an iRobot. That's the Create 3 robot, a programmable robot. On the right you can see what the challenge is. The challenge is the robot has to navigate this curvy course, eventually show up at a wall, and then do a wall following command and go down the wall. That is a challenging project right there by itself. But as the robot heads down the wall, it also has to joust a competing robot. So let's take a look at one example solution that these students were able to come up with. So what you're looking at on the screen, I think his name was Sir Mr. Potato Head, and that is a robot designed in Onshape. You can see on the left that the students were able to model the knight body and also the parts of the horse. And in the other two, the middle and right image, you can also see that the knight was outfitted with some armor, and you can see that the horse was mounted onto the iRobot. Now, the armor you can see was generated using some custom features, sometimes called a living hinge, where if you can accurately cut with a laser rigid material, you can actually turn that rigid material into a flexible material using that living hinge mechanism. On the far right, you can see that they actually embedded a fair amount of electronics in the final design, that the horse actually galloped, his eyes lit up, and there were a couple motors and a microcontroller all embedded in this system. And one of the things I like about this project is this is just a one semester project that students also had other things going on, and they were able to generate a fairly complex and creative and ultimately successful robot using Onshape. And I think a big part of it is how Onshape enables collaboration and that rapid prototyping process. So you can see in this final image that Sir Mr. Potato Head successfully navigates the course, travels down the straight line, and is able to be victorious in the joust. Now, clearly, these students learned a lot about design, about collaboration, and about robotics in this process. But I think you can also tell the students definitely had fun in the process. And as a teacher, I can tell you that if you can have the time and the tools to embed a little bit of fun in the process, that's going to go a long way toward achieving your learning objectives. So I'm going to turn it back over to Matt to talk about some exciting upcoming events.
Awesome. Thanks, Matt. So real quick, we're very excited to announce for here the first time our second annual Onshape Research Symposium. So if you liked what you saw here today, get ready for so much more. August 2nd from 10 a.m. to 2 p.m., an entirely virtual event. You can scan this QR code, and I think Peter will put a link in the chat to our Zoom registration link. We're going to be hosting our second annual student research poster competition for any college or university students, undergrads and grads welcome. It's a great opportunity to learn some more about these cutting-edge applications for Onshape. We're also excited to announce again the LiveWorks 2023 is happening at the Seaport in Boston from May 15th to 18th, 2023. You can register today using the code OnShapeLive. Hopefully those first 100 passes haven't been snatched up yet. If you're an educator and wondering, is this right for me? It certainly could be. The focus is on all of the commercial customers using PTC technologies, but it's a great way to learn about what's going on in industry and what you can be bringing into your classroom. And with that, I think we can hop into the question and answer phase. And I see that there's a lot of exciting questions coming in from the chat. So a first question was actually about the features that we highlighted while I was introducing FeatureScript. So I'm going to quickly hop back in the slideshow to show those 3 features. And Peter mentioned that there's also been a great discussion about the best ways of taking your Onshape designs and sending them to a laser cutter. So hopefully you have gain some insight and learn from each other about the best practices there. So here's that example of going from this 7-sided just shape into a laser cuttable object or design in just 3 features. So first we use the multi-thicken tool, which any face that you select will become its own part that's with a specified thickness. Then we use the laser joint feature, and you can specify how many tabs on overlapping flat faces you want. And then we use the auto layout custom feature. So of course, the last step would then be, how do I get a DXF or SVG of that flat shape sent to my laser cutter? Unfortunately, there's no kind of one solution because each laser cutter is so different with what they require. So my solution is typically to create a new sketch and use all of those faces, which I can then export as a DXF, which my Glowforge accepts. But we're happy to work with you to come up with a best solution if that doesn't work for you. I see another question was about the pulleys custom feature. Matt, I'm not sure if you have that link handy or are able to pull it up quick.
I can pull it up real quick. What was the question about the pulleys? So I think I misread the question. I was pulling up, the spheres, yes. I'm creating a public version of the spheres document as we speak. I'll also do the same for the pulleys, and I'll drop a link in the chat.
Awesome. On the fly, agile in our questions during Onshape Live. I love it. So we've gotten a couple of questions about that I think are related to the REST API. So one question from Mohammed was, I'm working, can Onshape create unique identification from parts of assembly itself? This is something which I think is not used or considered in other software. And then we had another question from Abduziz about using Onshape for machine learning. And both of those, I think, are most closely related to Onshape's REST API. So you can use the REST API with any coding language that you're familiar with. Python is a popular example, one of my favorites. And to answer that first question about assemblies, yes, you can you can get information about your assemblies, about the geometries and their relation to each other directly through that REST API. So you can go to Onshape's developer portal and learn a whole lot more there. And taking that one step further, researchers are using this for machine learning. So there's a great example of a paper from the University of Washington called Automate, where researchers built a huge data set from Onshape assemblies, from public documents, and they were able to generate a smart mate tool that would predict where the mates should go given the geometries that you imported into an assembly. So long answer, but the short answer is yes, there's lots of exciting ways for Onshape to be used for machine learning.
I just put a link to the spheres array in the chat, right? I believe. And now I'll put the pulley in there in just a second. And if there are any questions about either of these, happy to talk about it. And also, Matt, I just wanted to mention, at my school, we did a ton of laser cutting. So we were constantly using custom features for laser cutting. One of my favorites was called T-slot joint, I think, that created that very common geometry that if you're going to assemble laser cut parts using hardware, that you could do that. And in fact, we realized when we were modeling, we wish there was a make connector where we were going to put the nut for that custom feature. We were able to email the person who wrote it. They added that within minutes, created an update to the feature, and then all of our features, even if we'd already used them, we were able to just update our features, and there it was. Great solution.
Awesome. Yes, the Onshape community never fails to impress me. Post in the forum and you'll get 5 responses in minutes. Oftentimes folks are even willing to edit their custom feature to fit your needs, which is so exciting. One maybe last question to quickly touch on is about how Onshape can be used in electrical design and electromagnetism research. So as you may have heard, Onshape has a new capability called PCB Studio, which at the moment is not actually included in the education plans for Onshape. We hope to be providing that soon, but that only allows you to go back and forth between your ECAD and MCAD, your electrical CAD and your mechanical CAD. So while there's maybe not that many direct built-in tools for electromagnetism research, you can use Onshape to come up with your own integration. So whatever tool, let's say you're using MATLAB to use equations to derive the number of coils your electromagnet needs, you can use the output of that script to drive the number of coils in a helix in an Onshape sketch in real time. So you can really sync your systems and drive your Onshape geometry with your computation. So many opportunities for extensibility. And I think that's about the end of our time. Again, I'll just quickly give a plug for our Onshape Research Symposium this August. Please join us there. And we're so excited to have you all with us. And we hope you enjoy the rest of your time at Onshape Live.